Here's some additional particle to mole conversion practice problems. Keep in mind when we say particles, we're referring to atoms, molecules, formula units, ions, cows, horses, whatever the case may be. Regardless of what particle we're referring to, if we have 1 mole, we're always going to have 6.02 times 10 to the 23rd particles. Okay, this is going to be our main conversion factor here. 1 mole equals 6.02 times 10 to the 23rd particles. So for example, if we have 3.54 times 10 to the 24th atoms of copper, how many moles of copper is this? So we have atoms. Atoms is going to refer to particles. Okay. To solve these problems, we're going to set up our T-chart. The top left corner will always be what you're given in the problem. So we're given 3.54 times 10, restart. Here's some additional sample particle to mole conversions. Keep in mind when we say particle, it could be any number of things. It could be atoms, molecules, formula units, ions. It just depends on what you're given in the problem. Regardless of that, keep in mind if you have 1 mole of anything, you're going to have 6.02 times 10 to the 23rd particles, or 6.02 times 10 to the 23rd of those things. 1 mole is always going to equal this. This is Avogadro's number. So for example, if we have 3.54 times 10 to the 24th atoms of copper, we want to know how many moles of copper is this. 1 mole is going to be equal to 6.02 times 10 to the 23rd particles. Okay. Since we're looking for moles, atoms is going to be the particles. Keep that in mind. So first thing I want you to do is just make a prediction. Based on this number, are we going to have more than 1, less than 1, or equal to 1 mole? If you look at this number, we should have more than 1 mole because we have more than 6.02 times 10 to the 23rd. But let's go ahead and solve it so we can figure out exactly what we have. So we start off with our T-chart, which is what we use for dimensional analysis for converting between units. In this top left corner, you always put what you're given in the problem. So I have 3.54 times 10 to the 24th atoms. Always put your units. Okay? Since I have atoms here, I also need to have atoms here. That way, algebraically, they can cancel out. And then I'm going to be looking for moles. Keep in mind, this right here is our conversion factor. If I have 1 mole, I'm going to have 6.02 times 10 to the 23rd atoms. Okay? Atoms and atoms will cancel out. We'll be left with moles. All we have to do at this point is multiply across. So then we'll get 3.54 times 10 to the 24th over 6.02 times 10 to the 23rd. When it's over like this, that means we're dividing. The top number divided by the bottom number. So 3.54 times 10 to the 24th divided by 6.02 times 10 to the 23rd will give us approximately 5.88. And our unit, since atoms and atoms canceled out, is going to be moles. So we have about 5.88 moles of copper in this amount of copper. Alright, next problem. If we have 7.85 times 10 to the 23rd molecules of glucose, which is C6H12O6, how many moles of glucose is this? Notice this time we have molecules instead of atoms. That's because glucose is a covalent compound, whereas copper was an element by itself. Regardless of that, 1 mole of anything is going to be 6.02 times 10 to the 23rd of that thing. So again, use our T-chart. Start with our given. 7.85 times 10 to the 23rd molecules. If we do our prediction again, if I have 7.85 times 10 to the 23rd, that's slightly larger than 6.02 times 10 to the 23rd. So I should have a little bit more than 1, okay, as my answer. If I have molecules on top here, that means I have to have molecules on the bottom here so that they can cancel out. Molecules. And of course, 1 mole. Looking at my conversion factor up here at the top, 1 mole is going to be equal to 6.02 times 10 to the 23rd molecules. Multiply across, and we'll get 7.85 times 10 to the 23rd times 1 is going to be 7.85 times 10 to the 23rd over 6.02 times 10 to the 23rd. When you divide this, you get approximately 1.30 moles of glucose, as molecules and molecules canceled out and we were left with moles. Next problem. This time we have 100 molecules of carbon dioxide. How many moles of carbon dioxide is this? Okay. We only have 100 molecules. We need 6.02 times 10 to the 23rd particles to equal 1 mole. We only have 100, so we're not going to be anywhere close to 1 mole. Well, let's go ahead and solve for it. T-chart. 100 molecules. Molecules on top, so we need molecules on bottom. And mole on top. In our conversion factor, 1 mole is 6.02 times 10 to the 23rd. Multiply across, and we get 100 over 6.02 times 10 to the 23rd. When we divide, we get 1.66 times 10 to the 22nd. So if you notice, this time we have to the negative 22nd power. What you have to keep in mind is you're moving the decimal 22 times, but in the negative direction, so to the left. So if we move to the left, that number is going to be way less than 1, which is exactly what we predicted. Just keep in mind that your unit to put is moles. If we have 3.01 times 10 to the 23rd atoms of zinc, how many moles of zinc is this? Zinc is an element by itself, so we say atoms. Start with our T-chart. Our given is 3.01 times 10 to the 23rd atoms. Since we have atoms, we need atoms here and mole on top. 1 mole, of course, is 6.02 times 10 to the 23rd atoms. Now again, if we were to make predictions, 3.01 times 10 to the 23rd is less than 6.02 times 10 to the 23rd. So we should have less than 1 mole. In fact, if you notice that 3.01 is exactly half of 6.02, that would be a pretty good assumption, since they're both times 10 to the 23rd. But we'll type it into the calculator just to make sure. Atoms cancel out. Multiply across. Multiply across. 3.01 times 10 to the 23rd over 6.02 times 10 to the 23rd. And yep, our answer will be 0.5 moles.